Example 6.6 Apollonius theorem. If D is the midpoint of the side BC of a triangle ABC, show by vector method modulus of AB vector square plus modulus of AC vector square equal to 2 times modulus of AD vector square plus modulus of BD vector square. So take a triangle first. You can take A as the origin. Then AB vector, that is the position vector of B as B vector. AC vector, the position vector of C as C vector. D is the midpoint of BC. So let A be the origin, AB vector is B vector, AC vector is C vector. It is given D is the midpoint of BC. So if D is the midpoint of BC means you can find the position vector of that AD vector. AD vector is equal to what? The average of the position vector of B and C. So it will be AB vector plus AC vector by 2. It is B vector plus C vector by 2. Now you can find modulus of AD vector the whole square. This term I am finding now. So modulus of AD vector the whole square is, when there is square you can remove modulus. So AD square you can write, AD vector square you can write. It is AD vector dot AD vector. So I am replacing the value of AD vector here. Now how we can write is, it is equal to 2 into 2 it is 4. That 1 by 4 you can write outside. Then here we have B vector plus C vector the whole square. So you can expand it 1 by 4 into B vector square plus C vector square minus 2 times B vector dot C vector. Okay. So now you can find the next value. Next value is modulus of BD vector the whole square. So first we can find BD vector. BD vector is equal to, how you can write this BD vector? The position vector of the second term, that is AD vector, minus the position vector of the first one, that is AB vector. It is equal to AD vector you want to find, isn't it? AD vector already we have found out, it is B vector plus C vector by 2 minus AB vector. AB vector is B vector. Now you can take the LCM and simplify it. So B vector plus C vector minus 2 times B vector divided by 2. It is equal to B vector minus 2B vector means minus B vector you will get. So C vector minus B vector by 2. This is the value of BD vector. So BD vector is equal to C vector minus B vector by 2. Now you can find modulus of BD vector the whole square. Now you can find BD vector, that is modulus of BD vector square. It is equal to BD vector square. It is BD vector dot BD vector. So it is equal to BD vector is C vector minus B vector by 2 dot C vector minus B vector by 2. So it is equal to 1 by 2 into 1 by 2, it is 1 by 4. 1 by 4 into C vector minus B vector the whole square. Okay, C vector minus B vector the whole square. It is equal to 1 by 4 into, you can expand it now, C vector minus B, that is C vector square minus plus B vector square minus 2 times B vector dot C vector, or C vector dot B vector also you can write. To prove modulus of AB vector square plus modulus of AC vector square equal to 2 times modulus of AD vector square plus modulus of BD vector square. So first you can consider what is given inside the bracket here. So modulus of AD vector square plus modulus of BD vector square equal to, these values already we have found out, that I have replaced here. 1 by 4 into B vector square plus C vector square plus 2 times B vector dot C vector, and the value of this is 1 by 4 into C vector square plus B vector square, 1 by 4 into C vector square plus B vector square minus 2 times C vector dot B vector we have. So now we can take 1 by 4 commonly outside. So 1 by 4 I am taking commonly outside. Here 2 times B vector dot C vector and 2 times C vector dot B vector you can cancel, both are same. So what you will get, B vector square we are having 2 times. So 2 times b vector square. Same way c vector square also we are having 2 times. So 2 times c vector square. That is equal to, now 2 you can take commonly outside. So 2 by 4 into, since we have square, this b vector you can write it as modulus of b vector. Modulus of b vector the whole square plus modulus of c vector the whole square. So it is equal to, you can cancel 1 2, it is 1 by 2 into, here instead of b vector you can write a b vector. A b vector the whole square plus a, instead of c vector you can write a c vector the whole square. Okay. In the left hand side what we have is a modulus of, in the left hand side we have modulus of AD vector square plus modulus of BD vector square. Now you can cross multiply to take this 2 to the next side. So it is, I am taking this 2 to the next side and this I am writing in the left hand side. So modulus of AB vector square plus modulus of AC vector square is equal to 2 times modulus of AD vector square plus modulus of BD vector square. So this only you want to prove.